Okay guys, this is our second attempt at doing one of these. As I get better, I will start introducing the starter activities that we always do at the start of lessons anyway. But for the moment, I'm just mastering the software and trying to give you something to do and help you finish off this chapter on projectiles. So, here we go. A particle is projected from point O with speed v meters per second at an angle of elevation theta, where tan theta equals 4/3. The point O is 42.5 meters above a horizontal plane. The particle strikes the plane at a point A 5 seconds after it is projected. Show that v equals 20 and find the distance between O and A. So let's get this drawn. First of all, if we lift out the key information, we've got a particle projected from a point 0 with speed v to an angle of elevation theta, so that's the angle above the horizontal, where tan theta equals 4/3. O is 42.5 meters above a horizontal plane, so it's above the horizontal plane, O, the point of projection, and it strikes the plane at point A 5 seconds after it's projected. So if we lift that out and put it on a diagram, we're going to have something like that. So O is the point of projection, A, t equals 5 seconds. We're told tan theta equals 4/3. So we can draw the triangle. Theta, tan is opposite over the adjacent, and by Pythagoras, the hypotenuse then is 5. On the diagram, we've got a speed of v at an angle theta. And we know that the height above the plane is 42.5. All right, I think we've lifted everything out there, just scanning through. Okay, so show that v equals 20. Well, for that, we're going to need to know the time of flight. Most of these projectile motion questions revolve around finding the time of flight and then using it in a context. So if in doubt, I would do that first anyway. So, Part A. Projectile motion. So that's going to tell us that we're in a constant acceleration context. And if we're looking for the time of flight, we need to consider the vertical motion. Define our positive and then look at the information we've got. So u, the vertical speed. Well, let's go back to our diagram. Break down the velocity into its components. So in the horizontal direction, we've got v cos theta. And in the vertical direction, we've got v sine theta. So horizontally is v cos theta, v cos theta. Cos theta, we know, is 3/5 from our triangle. So u is 3/5 v. Except we don't want cos, do we? Because we're working vertically. So let's get rid of that and just do that again. So v sine theta, and sine is 4/5 of v. Okay, next, A is going to be negative g, because gravity is acting downwards. T is the time of flight, which we're told is 5 seconds. And S equals 42.5. Now there's a mistake there. Can you see what the mistake is? Yeah, hopefully you spotted it. The distance is negative 42.5. It's the distance down from O, and we've defined up as positive. Okay, we can now go into our usual routine of state, sub, solve. So equation with S, U, A and T in it. Any ideas, Jack? Yep, sure you got it right. S equals UT plus a half AT squared. So S is negative 42.5. U is equal to 4/5 of V minus or plus a half negative G 5 squared. So if we start to work that out, we've got 25 over 2G. So 25 over 2G added to both sides minus 42.5 is equal to 4/5 of V. Multiply through by 5, divide by 4. So we get 125 over 8G minus 42.5 times 5 is 212.5. 212.5 over 4 equals V. And I'm trusting that when we chuck that in the calculator, V comes out to be 20. You can check it. Let me know if I've made a mistake. Okay, part B. So part B asks us to find the distance between O and A. Now, here you've got to really make sure that you've read the question carefully. Yeah? Find the distance between O and A. Yeah, the distance between O and A. That's not the distance from the base to A, but the distance from O to A. Lots of people will miss that in the question. Okay, but to work out the distance OA, the first thing we've got to do is work out the horizontal distance from the base of the cliff. So we need to first of all work out the distance from the base of the cliff to A, and then we're going to use Pythagoras. Okay, so first of all, part B, we need to work out the horizontal distance travelled, which we've already done. So it's constant acceleration, positive horizontally. We know S is what we're trying to work out. T we know is 5 because it's the same time as flight as before. A we know is 0 because there's no horizontal acceleration. And we know that U is 20 cos theta. Cos of theta this time is 3/5 from our triangle. So we've got 20 times 3/5, which is equal to 12 meters per second. Okay, usual approach then, state, sub and solve. So S equals UT. There's no acceleration, so we don't really need the plus a half AT squared. So S is what we're trying to find. U is 12. T is 5. So we get 60 meters. And now the bit that lots of people have missed. Therefore, the distance OA is the horizontal distance squared plus the vertical distance squared square rooted using Pythagoras. So we get the distance between OA as roughly 74 meters. Again, you can tap it in the calculator to check that's right. Okay. Now, on the back of that, the work that you really ought to do, once you've made sure you've made notes and understood on that, is exercise 6.C, exercise 6C. Oh, let's get that written in a way which is legible, even by my poor standards. So exercise 6C. Questions. One to 9. Okay. Next lesson, I'll go through the remaining 2 examples on this section, and then we can give you the remainder of the questions to do. Okay. Hope that gives you a start, and good luck, guys.